Now let's look at some examples of compass and straight edge constructions. The first example will be to construct a perpendicular bisector. So we have a given line segment AB, and I want to construct a perpendicular bisector of this segment. So I can use a ruler for my straight edge, although when we do these constructions, we can't use any measurements on the ruler. I have my compass. What I need to do is draw two circles with centers A and B with radius the length of segment AB. I can start at either endpoint. Let's start with center A, and I'm going to draw just some arcs of the circle, above and below line segment AB, and then I'm going to come to put my compass on point B and do the same thing, and I can draw a circle, and then all we need to do is connect the 2 points of intersection of these two circles. This will produce a line that's perpendicular to line segment AB, and it bisects the line segment AB. This next construction, we're going to construct a parallel line to a given parallel line through a point P that's not on this line. So what I'm going to first do is, just like the last construction, I need a line segment on this line, and I'm going to make a perpendicular bisector of that line segment through point P. So to do that, I just need to make a mark, which is really a circle centered at P with a radius that's larger than the distance from P to the line. So I'm going to put 2 marks here and here. And those will be my 2 points that define my line segment. Without changing my compass, I'll come down here and draw an arc for a circle centered at this endpoint, and another circle centered at this endpoint. And then I can connect point P to this point of intersection, these two circles. And we have a perpendicular line through point P. Then I'm going to draw another line that's perpendicular to this vertical line through point P. And so I'm going to set my compass a little bit smaller. And let's make a line segment with P as the midpoint. So there's 2 points, and so this is P is the midpoint of this line segment. And then I'm going to open my compass a little bit farther. I'm going to start at the endpoint and draw marks here and here for a circle centered at this point, and use the same arc, use the same radius to make 2 more marks. And by connecting these 2 points of intersection, I will create a line that's perpendicular to this vertical line, and therefore it'll be parallel to the given line, and it'll be passing through point P. And for this next construction, we have a given angle, and I want to construct an angle bisector. So I want to draw a ray that bisects this angle. So I'm going to start with drawing a circle centered at the vertex of this angle. And so I just need 2 marks here and here on both sides of the ray of the angle. Then I'm going to take that from the same measurement, the same compass measurement, and draw a circle centered at this point and an arc on the center of the circle centered at this point. And then if I connect the vertex to this point of intersection, I will have created a angle bisector. Next, I want to construct an equilateral triangle with a given line segment as one of the sides of the equilateral triangle. So this is one of Euclid's propositions that we can, given any line segment, we can make an equilateral triangle with that line segment as one of the sides. All I need to do is draw two circles with radius equal to the length AB. So I can start at circle at center A, and then another circle with center at B. And since this is the same radius, you can see where the equilateral triangle will be. I can connect this point, call it C, with A and B to make the other sides of the equilateral triangle. And since AB is congruent to itself, AB is congruent to BA, and these are both radii of the same circle, then all three of these sides are the same, are congruent, and therefore this is an equilateral triangle. Here is a drawing of the solution in Euclid's Elements. This is Book 1, Proposition 1. So given a finite straight line, describe an equilateral triangle, and we see that we have the same construction.